Welcome to our lesson on coordinate geometry. Today we'll be covering three fundamental concepts: the distance formula, the midpoint formula, and the equation of a circle. These concepts are all closely related and build on the Cartesian coordinate system. Let's start with the distance formula. Given 2 points in the coordinate plane, how do we find the straight line distance between them? Let's say we have point A with coordinates x1, y1, and point B with coordinates x2, y2. To find the distance, we'll use the Pythagorean theorem. We can form a right triangle by drawing horizontal and vertical lines from one point to the other. The horizontal leg has length the absolute value of x2 minus x1, and the vertical leg has length the absolute value of y2 minus y1. By the Pythagorean theorem, the distance d equals the square root of the horizontal leg squared plus the vertical leg squared. This gives us the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's see an example. Find the distance between the points 1, 2, and 4, 6. Using the distance formula, we have d equals the square root of 4 minus 1 squared plus 6 minus 2 squared. This simplifies to the square root of 3 squared plus 4 squared, which equals the square root of 9 plus 16, which equals the square root of 25, or 5. So the distance between the points 1, 2, and 4, 6 is 5 units. Now, let's move on to the midpoint formula. The midpoint of a line segment is the point that divides the segment into two equal parts. Given 2 points A with coordinates x1, y1, and B with coordinates x2, y2, we want to find the coordinates of the midpoint M. The midpoint formula tells us that the coordinates of M are simply the averages of the corresponding coordinates of A and B. That is, M has coordinates, the average of x1 and x2 and the average of y1 and y2, or written as a formula, M equals the point with coordinates x1 plus x2 divided by 2, y1 plus y2 divided by 2. Let's work through an example. Find the midpoint of the line segment connecting the points 1, 2, and 4, 6. Using the midpoint formula, we have M equals the point with coordinates 1 plus 4 divided by 2, 2 plus 6 divided by 2. This simplifies to the point with coordinates 5 divided by 2, 8 divided by 2, which equals the point 2.5, 4. So the midpoint of the line segment from 1, 2 to 4, 6 is the point 2.5, 4. Now, let's move on to the equation of a circle. A circle is the set of all points in a plane that are at a fixed distance, called the radius, from a fixed point, called the center. Let's say we have a circle with center at the point H, K, and radius R. For any point X, Y on the circle, the distance from this point to the center must equal the radius. Using the distance formula, we can write the distance from point X, Y to the center H, K equals R, which gives us the square root of x minus h squared plus y minus k squared equals r. Squaring both sides, we get the standard form of the equation of a circle x minus h squared plus y minus k squared equals r squared. Let's see an example of a circle equation. Find the equation of a circle with center at 2, -1, and radius 3. Using the standard form, we substitute h equals 2, k equals -1, and r equals 3. This gives us x minus 2 squared plus y plus 1 squared equals 9. Here's what this circle looks like in the coordinate plane. Sometimes we encounter circle equations in the general form: x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are constants. We can convert this to standard form by completing the square. Let's see the steps for converting. First, we group the x terms and y terms together. Then, we complete the square for each group. For the x terms, x squared plus dx equals x plus d over 2 squared minus d over 2 squared. Similarly for the y terms, y squared plus e y equals y plus e over 2 squared minus e over 2 squared. Rearranging the equation, we get the standard form with center at -d over 2, -e over 2, and radius squared equals d over 2 squared plus e over 2 squared minus f. Let's complete our lesson with one final example. Convert the equation x squared plus y squared minus 4x plus 6, y minus 3 equals 0 to standard form, and identify the center and radius of the circle. First, we group the x terms and y terms: x squared minus 4x plus y squared plus 6, y equals 3. Next, we complete the square for each group. For x terms x squared minus 4, x equals x minus 2 squared minus 4. For y terms, y squared plus 6y equals y plus 3 squared minus 9. Substituting back x minus 2 squared minus 4 plus y plus 3 squared minus 9 equals 3. Simplifying x minus 2 squared plus y plus 3 squared equals 3 plus 4 plus 9, which equals 16. Therefore, the circle has center at 2, -3, and radius 4. To summarize what we've learned today, we covered the distance formula, which calculates the straight line distance between 2 points. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. The midpoint formula gives us the point exactly halfway between 2 points. M equals the point with coordinates x1 plus x2 divided by 2, y1 plus y2 divided by 2. And the standard form of a circle equation x minus h squared plus y minus k squared equals r squared, which represents a circle with center at h, k, and radius r. These formulas are foundational in coordinate geometry and will help you solve many problems involving points, lines, and circles in the Cartesian plane. Thank you for watching. I hope this video helped you understand these important coordinate geometry concepts.